Right, suppose we have an inelastic collision. Let's write every formula that or every equation that requires its velocity and its mass before and after collision using the conservation law. I think we've just finished discussing about that. So if it's before collision and then that which is after collision, when I'm talking about the conservative law, it's actually this expression here. Okay, so the first thing I will write is I'll be using m1. I'll be using initial velocity for before collision and then final velocity for after collision. All right, since we're talking about collision and we are considering two bodies, we say m1 u1 plus m2 u2. m1, the first mass with its initial velocity, and that's about to collide with another body of m2 with its own initial velocity u2, now equal to the final velocity m1 v1 plus m2 v2. Title this one equation 1. Now right now we're having different velocity, and that's because we are considering an elastic collision. All right, in an inelastic collision, they share common velocity after collision, but for elastic collision they do not share equal velocity. Now this actually the momentum formula for two body in collision. Now let's consider the kinetic energy for the momentum, that's before collision and after collision. And then the kinetic energy will be half m1 u1 square plus half m2 u2 square equal half m1 v1 square plus half m2 v1 square, equation 2. So what will happen is, I will multiply equation through 2 by 2. I'm going to multiply through by 2. So if I'm multiplying, let me just pick 1. But I don't want question to generate. I'm having half mv square. So if I multiply this by 2, this we cancel this, and I'll be left with mv square. All right, I haven't said that. So it means my equation 2 will become m1 u1 square m2 u2 square m1 v1 square plus m2 v2 square. I'm sorry. So this becomes equation 3. So I'm going to pick lifetimes from equation 3. m1 will come together with m1, m2 here we go meet m2 here. So it means equation 3 now becomes m1 u1 square, that's this one, this is coming here, so automatically it will become negative m1 v1 square equal m2 v2 square, that's this one is coming to make this one 2 here, so it will be m2 u2 square. Now I'm going to factorize m1 out. I have m1, I'll be left with m1 square minus v1 square equal m2 v2 square minus u2 square. Now looking at this, there's what we call difference of two square. Difference of 2 square, let me just kind of explain it here. Difference of 2 square, say a square minus b square equal a plus b, a minus b. This is what we call difference of 2 square, such that when you expand this, it will result back at this. Let's try it. A times a square, a times minus b, that is negative ab, plus b times a, that is ab, b times minus b, that's negative b square. this AB will cancel this AB. I'll be left with a squared minus b squared. All right, so everything here is the mathematical expression we use to expand this. So using difference of 2 squared, it means m1, I'll be having u1 minus v1 multiplied by u1 plus v1. The same thing applying for m2. I'll be having v2 minus u2 and v2 plus u2. Right, this what we'll be having, and then trying this, I'm going to tag this with a very big I. Okay, let's go to equation 1 and try and factorize m1 and m2 out, and then we are going to compare it with this very equation. So from equation 1 we have m1 u1 minus, sorry about that, m1 v1 equal m2 v2 minus m2 u2. I'll factorize m1 out and we're left with u1 minus v1. I'll be having m2 v2 minus u2. I titled this one equation 2. So having done this, I'm going to divide equation 1 and equation 2. Now when dividing it, let's take the left hand side. I'm having m1 and then I'm having u1 v1, sorry, minus u1 v1 divided by m1 u1 minus v1. m1 we cancel m1, u1 minus v1 we cancel u1 minus v1. I'm left with u1 plus v1. Okay, to equation 2, I'm having m2 v2 minus u2 and then v2 plus u2 over m2 v2 minus u2. Okay, m2 we cancel m2, v2 minus u2 we cancel this, so I'm left with u1 plus v1 equal v2 plus u2. So in other words, this u1 minus u2, that is if u2 comes here, I have v2 minus v1. So this I can also write this equation as u1 minus u2. If I factorize minus out, I'll be left with v1 minus v2. I know some people will be confused. Let me show you the expression. v1 minus v2. Negative times v1, that is negative v1. Negative times negative, that is positive v2. You can see that I've not changed the expression here. It's actually the same thing. Okay, so this equation will actually make me discuss about, and I want us to take note of this equation. I'm going to discuss briefly on the coefficients of restitution for a perfectly inelastic collision. All right, from this expression I can say u1 minus u2 divided by v1 minus v2 is actually the same thing as u1 minus u2 over v2 minus v1 is the same thing, equal 1. The question is, how did I get 1? If I divide both sides by minus v1 minus v2, if I divide both sides by it, this we cancel it. I'll be left with 1. Now, so this expression here, let me title it E. E is actually the coefficient of restitution. For a perfectly elastic collision, E1 equal 1. For a inelastic collision, E is less than 1. Now, if the bodies stick together after collision, it means that E equal 0. But I really want us to take note of this expression here. Take note of this expression here. Take note of this expression here. So this is derived from the conservation of momentum. This is the kinetic energy associated with momentum, and this is the coefficient of restitution. So let's dive in to solving problem on linear momentum, on impulse, on impact.